of the primary goals of reducing CO2 emission, which we have there. And what we can expect is that it is going only to grow. And if you look at into this diagram in here, the predictions are from 2024 to 2050 that it will more than double. It will, number of these refrigeration units is going to more than double. And primary growth is in China. This is this one, and India, which is this one in here. So that's where we are expecting to see that. So to set a scene for compressors, these are the challenges that we have for refrigeration, but also for other applications of these compressors. And obviously, we need to improve this compressor efficiency in order to reduce carbon footprint. And there are several ways of how we can do that. One is by designing more efficient machines. Another one is creating more sustainable lubrication, because lubrication also plays a part, because it's necessary to produce lubricants. So, a lot of lubricants is used, they are wasted, and etc., etc. But also possibly to remove them completely, to use oil-free machines in refrigeration. The challenge is that oil-free machines are not that reliable as oil-injected machines. So oil really cools them down and then makes them more reliable. But refrigerants are also very good coolants. So we don't need oil for cooling. We need oil just for a little bit of lubrication in there. So I think there is a lot of opportunity, and I believe that alongside with this growth of compressors that we have in here, we will see a growth of use of oil-free machines in refrigeration. At the moment, if you are looking into industrial refrigeration, specifically screw compressors, about 87% are oil-injected machines, and about 13% are oil-free. So I'm expecting that to change significantly in the future. And so that's what I'm referring here, especially for high temperature heat pumps, where you need a high temperature at the exit of the compressor. With oil injected machines, you can't achieve that. So you need oil-free machines to actually heat this up because they naturally heat up and you need refrigerants which have a higher gamma value or the ratio of specific heats. So to allow that, the main problem of oil-free machines is that they are not reliable. And they are not reliable exactly because of the high temperatures that exist in the compressors. Because oil is, in oil-injected machines, primarily injected to cool down the gas in a direct contact, or vapor in a direct contact with it, and to make it more reliable, because there is no thermal growth of the elements. Now, with oil-free machines, you have that. That was the first attempt that companies had in 1930s or earlier to introduce screw compressors like oil-free. And it was only Howden in 1950s who basically invented oil-injected compressor, trying to actually solve their problems. They made a mistake. They never patented it. But that's okay for them now. They're still one of the main companies. And then, so oil-free, but potentially water or refrigerant lubricated. So we have a lot of projects working on water-injected compressors because of reducing in other areas. It comes to a steam refrigeration, if you wish, or heat pumps with the steam. But in a classical refrigerants, hydrocarbons, and this refrigerants, then you can do with lubrication by the refrigerant. So these are the challenges, and that is the setup for the projects that we are doing at City University.